Now, we need to subtract a multiple of 10,000, so a number that ends in 4 zeros. First, we have 186,000 minus 30,000. Now, if we highlight our 10,000s digits, we can see that we have 8 10,000s and we're taking 3 away. So in our answer, we will have 5 10,000s and all of our other digits stay the same. So our answer is 156,000. Now, 224,284 minus 70,000. This time, if we highlight our 10,000s digits, we can see that 7 is larger than 2. So what we need to do here is to move to the left and highlight our 100,000s digit as well. Now 22 minus 7 is 15, so we can replace these digits here with a 1 and a 5. All of our other digits stay the same, so our answer is 154,284. Now 369,009 minus 70,000. If we highlight our 10,000s digits, again 7 is larger than the 10,000s digit in our question, so we need to highlight our 100,000s digit as well. So now 36 minus 7 is 29, so we can replace these digits here with a 2 and a 9 and then leave all of our other digits in the number that we were subtracting from the same. So our answer is 299,009. So if we look back to this first question, we can use place value counters to represent the number 186,000. Now because we're subtracting 30,000s, we need to subtract 3 10,000s, and when we do that, we can see that we have 5 10,000s, and then the other place value counters have stayed the same, so that's 156,000. But then here, we started with 224,284, which we've represented here. But we needed to subtract 7 10,000s, and we only had 2. Now what we can do is take away 1, 2 of our 10,000s, then we can exchange one of our 100,000 counters for 10 10,000 counters, because 10 10,000s has the same value as 100,000. So now we've already subtracted 2 10,000s, so let's subtract 3, 4, 5, 6, 7. And now you can see that we have 100,000 counter because we needed to take one to exchange, and we have 5 10,000 counters. So that's why we could do 22 minus 7 to get 15, and then leave all of our other digits the same because our thousands, hundreds, tens and ones have stayed the same. Then we had 369,009, which we can see here. We needed to subtract 7 10,000s because that's 70,000. We can subtract 1, 2, 3, 4, 5, 6, then exchange, then subtract our 7th 10,000. And now, because we've exchanged, we only have 2 100,000 counters and we have 9 10,000 counters. So that was why we could do 36 minus 7 to get 29 and then leave all of our other digits the same.